If we want to prepare our young engineers for the future, to make them able to respond to challenges, we have to think about education. We have to start at education. And the question is, what should be the contents for modern, up-to-date teaching? And I claim in this talk now that in addition to the basics, in addition to theory, we should teach not only structural but also conceptual design for all materials or independent of materials. The reason I asked myself this question is very simple. I joined the Faculty of Engineering in Berlin 2 years ago. You can find us in this beautifully restored old building of AEG. You see the old electrical company in the center of Berlin. This is our laboratory. Perhaps the biggest in Germany. It's about 180 meters long, so we can say we are well equipped, but only as far as room goes. There was a lot of restructuring in Berlin, and that actually made us forced us to think of the curriculum. It forced us to completely rethink. This is what we have been doing recently, and the first thing we tell our students is that they made a good choice. Structural engineering is a great profession. It's a profession where you can still build your own bridge, your own tower. You can contribute to civilization and to society by doing something visible. And it's one of the few professions that really combine sound, profound, scientific and theoretical knowledge with creativity. And I think that's special about structural engineering. Creativity comes free with childhood. What you see here is a bridge and a tower competition that we had at the day of the open door at our university. The Italians may forgive me, we built these towers with spaghetti. And these are some of the results that show children creativity. The left one looks a bit like the Bank of China in Hong Kong, doesn't it? The right one looks like the alien built it. But still both is creative, I would say. And we should not lose this creativity when we go to university. It should be promoted, it should be added, it should be fostered, and we should add also theoretical and scientific knowledge so that we end up being able to design lightweight and beautiful, robust and economic structures. The design process, I think, should be a conscious process. It should be a holistic process. We should think about our designs. We should be aware, and we should be careful that we don't only teach theory, because, well, we learned it yesterday. Leonardo would have said, does not work, not beautiful. Only theory is important, but it's not the only thing that should be taught. I think we need the basics, we need mathematics, mechanics, but on top of that, we need conceptual and structural design in education. So what is conceptual and structural design? Basically, it is what we do in reality. It is what we do every day when we work in the office, and what we do first. And surprisingly, that is not taught at many universities. What we do first is conceive a design, conceive a structure. That's the first step. It means a lot of sketches, a lot of thinking, and I think it's an important step, because if the birth of a structure is not done well, if the concept does not work well, we pay for it later during the dimensioning, during construction, or even during maintenance. So I think conceiving, the conception, the conceptual design is the most important step in this entire design process. It is then followed by some kind of abstraction. The planned reality is put into a model. So top right is the modeling. We get the forces, we do analysis, and then we use this analysis to dimension. We dimension the size of our structure, we dimension the reinforcement based on the forces, based on the analysis that we have done first with our abstract model. Detailing, the final detailing, the nodes, the connections that we see here at the bottom.